Consider this green body. It is not restrained in any way, meaning it is free to move horizontally, vertically, and rotationally. Now, let's consider that one end of this body is restrained or attached to a wall. In this case, we can say the body is fixed at one end, preventing any movement horizontally, vertically, or rotationally at that end. So, to restrain a particular end, we need to connect to a member. This is called a support. So, here we need to understand two main terms. 1. Restraints.
2. Supports.
Restraint refers to the restriction of movement at certain points or areas of a structure. A restrained point or end is prevented from moving in one or more directions, whether horizontally, vertically, or rotationally. Now, a support is a structural element that provides the necessary restraint to a body or component, allowing it to resist the loads placed on it. In civil engineering, supports are typically points of contact where the structure is connected to the foundation or other parts of the structure. These supports restrict movement at certain points and provide the force needed to keep the structure in equilibrium. The purpose of restraint is to prevent excessive movement or displacement that could compromise the stability of a structure. A restrained body can't freely move or rotate because it is being held in place by a fixed connection or support. Support in a structure are members that facilitate the supported structural element to bear or resist the load coming over it. For example, a column supporting a beam, or a beam whose one end is supported on a wall, etc. The support between the column and beam can be made through connections in many ways. For example, they can be connected as a fixed support, and the connection won't allow any movement of the joint during the action of load. But if the support joint is a roller joint, rotational and translation movement is allowed. Hence, this derives several types of support. Let's discuss various types of supports provided for structures and the restraints each support provides. Before analyzing a structure, the first step is to identify the type of support it has. This is important because each type of support provides specific restraints, which in turn generate corresponding reactions.
Think of it this way.
If a support prevents horizontal movement, it means the structure cannot slide left or right. To counter this, an internal horizontal reaction force develops. Similarly, if a support prevents vertical movement, an internal vertical reaction force is created to resist that movement. If a support prevents rotation, it generates a moment reaction to counteract any tendency to rotate. In structural analysis, our goal is to determine these reaction forces. That's why we always begin by identifying the type of support and understanding how many reactions it produces. This helps us solve for the forces acting on the structure and ensure it remains stable. Supports in structure can be either of two types. 1. External supports. 2. Internal supports. 1. External supports in a structure. Those supports are provided externally, without disturbing the structural members, are called the external supports. Internal supports are supports that are provided internally or within the structural members. This support hence disturbs and divides the structural element into parts. Therefore, the analysis is hence carried out as separate parts, and the external reactions are determined. The internal supports provided can be either an internal hinge or an internal roller. Let's first discuss external supports. The various types of support we will study here are 1. Fixed support. 2. Roller support. 3. Hinge support. To explain these types, let us consider a beam supported on a column. Here the support is a column. How is the member supported on column? Some sort of connection exists between the column and beam. Let's apply all possible supports and check what is the difference. Case 1. Fixed support. Let's give a fixed connection between beam and column and achieve fixed support. In the case of RCC construction, the beam can be constructed monolithically with the column. We perform concreting of column and beam together. Here, beam-column connection acts as a single unit. This type of support is what we call as fixed support. while the fixed support in the case of a steel column and steel beam is like this. In structural engineering, we do not perform analysis of the structure in its raw form. Instead, we draw their respective free body diagram for easy understanding and analysis. So, in structural analysis, we represent a fixed support like this. Let's now understand the associated restraints and reactions with a fixed support in structures. For understanding the fixed support in structures, let us consider a cantilever beam AB whose end is A fixed and the end B is free and subjected to an inclined load of B at an angle of theta. Now, under the action of load B, the deflection pattern followed by a cantilever beam is as shown in the figure. Now we will concentrate on each end and find out what will be the reactions at the ends or at the supports. Our first area of focus is end B, where the end B is a free end. Under the action of load B, there is deflection happening in the beam, but there is no deflection happening at A because A end is fixed. So here we concentrate at end B. We see that end B has deflected from a point, say B to be 1 at a distance of y, which is the deflection provided. So under the action of load B, the end A remains as such, but the end B deflects. Deflection at point B results in a displacement value, which is a known zero value, and this deflection pattern will have a corresponding slope to that deflection, which is given by theta B. So here at point B, there are no sort of reactions as the end is restrained. The end is free to move, so the support reaction at B is given as 0. So this simple concept, there is no kind of force or any kind of support that restrains the support B. Hence, there is no restrainment, there is no reaction. Now we will look into the end A. You can see that end A is fixed. The fixed end A restricts the movement of end B. When you look into the X, Y, and Z directions, you can see that the fixed end restrains the movement of that particular point along the X direction, along the Y direction, and along the Z direction. As a result, the displacement along the X direction is 0. There is no movement happening, so delta X equals 0. The displacement along the Y direction is also 0 since there is no vertical movement, so delta Y equals 0. Now, unlike end B, there is no deflection happening at A. This means the slope at A, theta, is also 0. Since there is no displacement along X, Y, or any rotation about Z, the rotational movement is also restrained. So, at end A, the horizontal, vertical, and rotational movements are completely restricted by the fixed support. A restricted end results in internal reactions at A. These reactions include translational forces as well as rotational moments. The rotational moment at A is caused by the applied force B. The restraining forces result in reactions along the X direction, Y direction, and rotational movement along the Z axis. Thus, there are 3 support reactions at A. Rx, horizontal reaction. Ry, vertical reaction. Mz, moment reaction about the Z-axis. These external reactions are essential when determining the indeterminacy of structures, which will be covered in the next video. These are support reaction in 2-dimensional. In 3-dimensional analysis, the support reactions at the fixed end will be Rx, Re, Rz, Mx, my Mz, where Re equals 6. And that's all about fixed support. Since this is turning into a long video, I don't want to make it overwhelming or boring. So I'll wrap up here, and in the next part we'll cover hinge support, roller support, and the second main classification, that is the internal supports. Stay tuned, and don't forget to subscribe so you don't miss it.